Earth, a 4.5 billion-year-old planet, still evolving. As continents shift and clash, volcanoes erupt, and glaciers grow and recede. The Earth's crust is carved in numerous and fascinating ways, leaving a trail of geological mysteries behind. In this episode, Krakatoa, one of the deadliest volcanoes in the world. More than 100 years ago, it erupted with such devastating fury that it wiped itself off the face of the Earth. In the process, it sent out the loudest sound in recorded history and killed more than 36,000 people. And now, this deadly volcanic beast is back. Geologists investigate one of the world's fastest-growing volcanoes to hunt for clues that will tell them if and when Krakatoa will explode once again with the same cataclysmic force. As they prise apart the rocks, the answers they find will be another piece of the puzzle of how the Earth was made. Krakatoa is one of the most dangerous volcanoes the world has ever seen. When it exploded apart in 1883, the blast was heard over nearly 10% of the Earth's surface. It was a worldwide clarion call announcing the awesome power of volcanoes. The site of this monstrous eruption lies between the Indonesian islands of Java and Sumatra, in a channel known as the Sunda Straits. Today, a new volcano has staked its claim in exactly the same spot. It's called Anak Krakatau, meaning the child of Krakatoa. Right now, it's in the middle of a new and extremely dangerous phase. Dr. Charles Mandeville traveled here to see if the child will one day be as deadly as its parent, to see if history is about to repeat itself. The stakes are high. At risk now are the 1 million people of Java and Sumatra who live within 50 miles of the volcano.
Oh wow, look at that. We got a little explosion going on. I've kind of been following this from the internet from my office, but it's actually good to kind of see the thing live again. I've noticed in coming here that the volcano itself has grown possibly as much as 250 to 300 feet since the last time I've actually stood on its crater back in 1990.
Growing at a rate of 12 feet a year, the 1,033-foot volcano is both one of the fastest growing and youngest volcanoes on the planet. This remarkable footage shows its explosive birth in June 1927, when it first broke through the seafloor and erupted out of the water. Its rapid growth is clear evidence that this new volcano is extremely active. But will it be as deadly as its parent? These eruptions are always accompanied by a series of ground-shaking tremors. For geologists, these small earthquakes are evidence that this volcano is entering a more destructive phase. Seismographs have been buried deep on Anak's slopes to record this underground activity. But these small quakes are not the only sign of a dangerously active volcano. A more subtle clue is right beneath Mandeville's feet.
Black sand beaches are very common in volcanic areas. The minerals and the glass fragments that comprise the ash that the volcano erupts is typically dark charcoal gray colored, and usually these materials don't stand up to weathering over long protracted periods of geologic time. But you find them in relatively fresh, pristine form when you're near an active volcano.
Krakatoa is rarely completely quiet. But the level of activity in 2008 shows that the volcano has become unusually violent. To discover just how much of a threat it could pose in the near future, volcano detectives must turn to their history books to learn what made its parent, Krakatoa, so destructive. This is a story that has fascinated geologists for over a century.
What got me switched onto volcanology was the 1883 eruption. I learned about this at school, and I remember thinking how incredible that an island could just blow itself into oblivion. You know, what was going on? What was that all about? What was special? You know, how does that happen, and could it happen again elsewhere on Earth?
Before it exploded in 1883, Krakatoa was an uninhabited island with 3 jagged peaks, covered in lush vegetation. It was part of the Dutch East Indies, a thriving, bustling hub of international trade. Indonesia's wealth of minerals and spices attracted many Western traders, journalists, and geologists. Their reports provide first-hand accounts of what happened before and during Krakatoa's deadly and shocking eruption. There had been no hint of volcanic activity in anyone's memory. No one had a clue that Krakatoa was about to blow. Beneath its green and placid surface, Krakatoa was a time bomb waiting to explode.
So the first idea the locals would have got that anything strange was happening on their island would have been in May 1883. Earthquakes, earth tremors.
These tremors reached as far as the capital, Batavia, more than 100 miles away. Few suspected that the island of Krakatoa, seen on the distant horizon, was to blame, and that these earthquakes were the first clue to its deadly potential. Then, on May 20th, 1883, Krakatoa announced that it was no mere island. One of Krakatoa's 3 peaks exploded with extreme force, shooting a plume of ash hundreds of feet into the air. But after these initial fireworks, the activity appeared to cease. The local population breathed a sigh of relief. Thinking it safe, the governor of the Dutch East Indies sent a research party of geologists to the island in late May, where they observed the scorched landscape and smoking crater with amazement. Their meticulous report gives modern-day geologists the first clue as to what lay behind Krakatoa's immense power. A key discovery was a layer of pumice 1 foot deep that covered the island's shores. This pumice is the solidified lava that comes from the heart of a volcano, and it's riddled with bubbles. These bubbles suggest to geologists that Krakatoa is a stratovolcano.
And those volcanoes tend to be the classic volcanoes that you see in textbooks. They're very steep-sided, like sort of sharp, almost triangular-type mountains.
These are the most dangerous types of volcanoes on Earth. They are fueled by molten rock called lava, known as magma when it's underground. The magma that flows through these volcanoes is like liquid dynamite.
Stratovolcanoes are dangerous because of the sorts of lava that they erupt. And the lava that comes out of stratovolcanoes is very sticky, viscous lava. And the danger there is that the sticky lava often contains large amounts of gas.
The bubbles inside the pumice discovered on Krakatoa in 1883 show that the magma was once packed with explosive gases. Because the magma was so sticky, a term describing its thickness and resistance to flow. The gas could not easily escape.
And the formation of gas bubbles in the sticky lava can be powerful enough to actually rip the lava apart, and in the process you actually tear away the volcano. The whole thing becomes explosive, and you produce very dangerous volcanic activity.
Krakatoa's magma had another deadly property.
In some situations, the lava can become so sticky that it sort of freezes up and congests or chokes up the volcano. It forms a kind of a plug or a seal. But what will happen is that over time, more magma is coming up and being trapped beneath that plug. At some time in the future, the pressure would be so great that there'd be so much magma wanting to get up that you just rip the plug apart, and that can produce, again, a catastrophic volcanic eruption.
This is exactly what happened at Krakatoa on May 20th, 1883.
From then onwards, over the summer, it quietened down a bit, but this was really the kind of calm before the storm.
The investigation into Krakatoa's deadly potential has produced important evidence. The frequent earthquakes on Anak Krakatau today indicate the volcano is still dangerous. The pumice from 1883 reveals that Krakatoa was a stratovolcano, its sticky, gas-rich lava making it dangerously explosive. Krakatoa's eruption in May 1883 was spectacular, but beneath the surface, Krakatoa was refueling. An even greater eruption was gathering force out of sight and out of mind. Anak Krakatau is one of the fastest-growing volcanoes in the world. Geologists are investigating its threat to the region. They have turned to the past to uncover what made its parents so deadly. In 1883, exactly 100 days after Krakatoa first blew, the volcano showed its true power. This final phase of eruptions began at 1 1 on the afternoon of August 26th. All three volcanic peaks erupted simultaneously, hurling dense clouds of ash and smoke an astonishing 17 miles into the sky.
The eruption of Krakatoa was one of the biggest volcanic events of the last few hundred years, and it would have been, to people observing it, it would have been like the beginning of the end of the world, if you like.
The power of this eruption was immense, like a giant jet engine aimed skywards. The air quickly became choked with tons of thick black ash, blotting out the sun.
So temperature, because of all the ash in the atmosphere, would be stifling, and if you were very near on for example, the west coast of Java, you'd be getting the ash in your throat and in your eyes. It would have been a real vision of hell.
And a nightmare that showed no signs of ending. By the next morning of August 27, 1883, Krakatoa's 3 craters had been raging for more than 14 hours. Then, sometime between 5:30 and 10:02 a.m., the land was deafened by a series of 4 huge explosions. The noise was so loud it could be heard over 2,000 miles away in the Australian desert near Perth. The third was the loudest recorded noise in history, the equivalent to 200 megatons of TNT, 13,000 times the size of the bomb that destroyed Hiroshima. What created this awesome explosion? The hunt for answers takes geologist Charles Mandeville to the jagged island of Krakatoa. This tiny island is in fact a part of the once mighty Krakatoa.
The record of what the volcano did from May 20th to August 26th to 27th is here, represented on the islands by the layered deposits that we see preserved in the jungle. This is a gold mine for a volcanologist trying to reconstruct the events that took place here, because each one of these deposits tells us something particular about what the volcano was doing.
This pumice was thrown out of the heart of the volcano in 1883. Mandeville believes that it holds the key to understanding the forces that destroyed Krakatoa.
What I have in my hand is a mixed pumice or streaked pumice, and what it represents is that we had two magmas mingling in the conduit of the 1883 eruption of Krakatoa.
The stripes are proof of the two types of magma inside Krakatoa. The lighter band represents the cooler, gas-rich magma that was present during the earlier eruption in May. This eruption only partially emptied the magma chamber. By August, this void was filled from deep below by searingly hot, dark-colored magma. When these two magmas mixed together, it was a lethal cocktail. The intense heat of the dark magma caused the huge amounts of gas within the light magma to expand.
The magma chamber that was holding this mixed bag became overpressurized to the point where it exceeded the rock strength of the roof rocks above it. And when that happens, you can get really rapid ascent of magma to the surface.
When this magma exploded from the surface, it ripped apart tons of rocks with an ear-splitting blast. This mega explosion caused the loudest noise in recorded history. The striped pumice on Rakata proves that magma mixing was the trigger. But Krakatoa wasn't just the loudest volcano in history. It was a killer. Because Krakatoa itself was uninhabited, some of the volcano's first victims were at Ketimbang, a village on the southern coast of Sumatra. But Ketimbang is on the mainland, 20 miles from Krakatoa, and separated by the waters of the Sunda Straits. How these people fell victim to the deadly ashes was a mystery. To uncover the answers, we have to return to the scene of the crime, Rakata, and to these imposing white cliffs. They may seem part of an ancient landscape, but these 200-foot white cliffs were laid down in a matter of hours. They are what's left of a raging torrent of hot gas and rocks, a terrifying force of nature known as a pyroclastic flow.
Pyroclastic flows travel extremely quickly, so you can't outrun them. They're also extremely hot, several hundred degrees centigrade, so they will, if you're caught in the middle of one, they will incinerate you instantly.
Perhaps the most famous victims of a pyroclastic flow lie at Pompeii, the Roman settlement that was utterly destroyed during the eruption of Vesuvius in Italy in the year 79. The perfectly preserved remains of the people here are testament to the power of these fiery avalanches.
And most people die not because of 100% burns, but because they inhale the gases which are so hot that they just destroy the air passage in the lungs instantly. And so after 2 breaths, you're dead.
The sheer size of the cliffs at Rakata have led geologists to estimate that the pyroclastic flows thrown out by Krakatoa were an amazing 2,800 feet high. But the victims of this deadly torrent were on the other side of the Sunda Straits. What happened next was truly astonishing.
Pyroclastic flows are ground hugging. In other words, they follow the ground surface as they go down, but they also have an upper part which is very rich in gas, so it's low density. Now when a pyroclastic flow hits the sea, the dense bit carries on down onto the ocean bed, but the gas rich but still very hot bit goes hurtling across, scooting across the top of the water. There's virtually no friction between the gas and the water, so it can travel a very long distance.
Over 2,000 people at Ketimbang perished from the burning debris that could not just walk on water but run. at amazing speeds of up to 200 miles per hour across 20 miles of open sea. The investigation into the Krakatoa volcano has pinpointed the extraordinary force that ripped the island apart. Striped pumice is proof that magma mixing created the vast explosion. 200-foot cliffs on the island of Krakatoa are evidence of vast pyroclastic flows, big enough to cross the ocean and claim the volcano's first victims. But contemporary reports show that most of Krakatoa's victims were not killed by these deadly avalanches, but by a very different force of nature. August 1883, Krakatoa's second and most deadly eruption. More than 2,000 people were killed by searingly hot pyroclastic flows. But there was worse to come. These gigantic boulders are on the shore of Anyer in Java, 22 miles away from Krakatoa. They are a crucial clue to what the volcano did here, and a stark reminder of what could one day happen again. They are made of coral, which can only grow underwater. So some immense force unleashed by Krakatoa must have put them here. These shattered bricks are another piece of the same puzzle. They are all that remain of a lighthouse that once was one of the sturdiest buildings on the Java coastline, but no match for Krakatoa.
I'm standing at the top of the new lighthouse in Anyer, 120 feet above sea level, built 2 years after the eruption of Krakatoa in 1883. The old lighthouse down there is nothing but a trace of bricks because it was wiped out by a large tsunami.
Eyewitness accounts detail the exact height of this terrifying wave.
Difficult though it might be to comprehend, the momentum of that wave would have taken the water up to the level that I'm now standing.
Krakatoa's death throes had triggered a massive wall of water that now raced towards the shore at Anyer.
I don't think anyone living along the shores of Western Java or Southern Sumatra would have known about the tsunami that they were about to face, and certainly nobody would have been able to survive those sorts of wave heights.
The power of the wave can be seen in this 600-ton block of coral that was ripped from the seabed and smashed the lighthouse to pieces. Still here today, it provides some of the clearest evidence of the immense power of Krakatoa's 1883 eruption. The same wave that shifted this boulder also destroyed houses, villages, and transport, leaving nothing but twisted wreckage behind. The mighty wave even picked up and stranded a Dutch steamer, the Beru, 2 miles inland. This immense tsunami claimed the lives of more than 34,000 people.
It's quite possible that those people who lived in the villages in Western Java and Southern Sumatra thought, well, the volcano's out there somewhere, it's an island, so it can't possibly affect us here. But of course, the eruption itself triggered the tsunami, which meant that the water adjacent to the volcano was being displaced right across to where they lived. So, you know, that feeling of safety was sadly misplaced.
For modern-day investigators, the puzzle was how fire and water had combined to wipe out an entire region. The evidence came from the shattered remains of the volcano itself, Krakatoa Island, part of one of Krakatoa's 3 original peaks. Its sheer vertical cliff face tells volcano detectives about Krakatoa's final moments.
When you have a very large volcanic eruption, you evacuate a lot of magma. It leaves behind effectively a hole, so quite often the crust just collapses down into that hole, and that leaves behind what we call a caldera.
Krakatoa had ejected such vast amounts of burning magma and rock, it could no longer support itself. Drain away the water, and we can see how it collapsed, creating an immense caldera.
So this cliff behind me marks the edge of the 1883 caldera. Under the boat, this water depth is about 40 times as deep as most of the area around us. The scale of this collapse is pretty big. It formed a caldera that's about 3 miles in the north-south direction by about 5 miles in the east-west direction.
This immense collapse has only occurred once in recorded human history. The combined weight and power of Krakatoa's awesome pyroclastic flows and this huge collapse was more than enough to trigger the tsunami. The riddle of just what had caused Krakatoa's tremendous tsunamis had finally been solved. When the smoke had cleared and the waters receded from the most devastating eruption in recorded history, the island of Krakatoa had vanished. In total, Krakatoa had killed 36,417 men, women, and children. It was, without doubt, one of the most dangerous volcanoes in history. But while investigating the 1883 eruption, scientists discovered ancient lava flows hidden in the jungle and on the seabed. This deadly volcano had struck before. But when scientists dated the lava flows, they hit a problem. Radiocarbon dating was only able to place the eruption to between the 1st and 13th centuries, a spread of 1,200 years. Scientists needed more information in order to try and shed light on a new Krakatoa threat and help the hundreds of thousands of people living in the area. The trail of evidence at Krakatoa had gone cold, literally. Because thousands of miles away from the sweltering heat of Indonesia, in the frozen wastes of the Antarctic, scientists recently discovered a critical clue to Krakatoa's explosive past.
Well, ice cores are cylinders of ice that we drill from the ice caps in Greenland and Antarctica. You look at things like volcanoes. Any material coming from surrounding oceans make its way to Antarctica, where we can detect it in the ice. You might imagine that we see the dust and the ash from a volcano, but in fact very little of that from the big Indonesian type volcanoes ever makes it to Antarctica. So what we do see is sulfuric acid. Big volcanoes spew out a lot of sulfur dioxide into the atmosphere, which is oxidized into the sulfuric acid, which we then measure in the ice.
The sulfuric acid cannot be seen in the ice cores with the naked eye, but can only be detected back at the British Antarctic Survey's lab, where the cores are kept at a continuous minus 13 degrees Fahrenheit.
So this is a piece of core from Antarctica. This is a piece from James Ross Island. It's about 10,000 years old, this ice. What we're doing now is measuring the volcanic signals. And what we see is very, very distinct, clear electrical pulses that come from the sulfuric acid from the volcanoes. So very quickly we can see all the volcano signals throughout the whole core.
One of the strongest signals found in the ice cores is from the 1883 eruption of Krakatoa.
What we can see from the 1883 eruption, we can't see the ash, but we can see a very large peak in sulfuric acid. In fact, it's one of the biggest peaks we've got in the last 1,000 years. It's such a big peak, in fact, that we use it to date the ice cores because it's like a reference horizon that we can see there.
Each ice core is like a diary of the Earth's climate. Each layer of ice represents 1 year. In the same way that we can count tree rings, scientists can count back each layer of ice to determine the exact date of any eruption. Counting back from the 1883 signal, there is a huge spike in the sulfuric acid levels in the year 535. This is clear evidence of an enormous eruption during the dying days of the Roman Empire, an eruption far greater than Krakatoa's in 1883.
We are now beginning to come to the conclusion that yes, there was a large volcanic eruption in 535. In fact, it looks one of the biggest ones on the record in terms of how much sulfuric acid it put into the atmosphere.
The ice cores tell us a lot about this mystery volcano. Its eruption was so enormous that its impact was global. Its date falls exactly in the middle of the time span of the lava flows around Krakatoa. Could it be Krakatoa? The clues seem to fit. If they are the same eruption, this is evidence that Krakatoa has a far more deadly past. And potentially a far more deadly future.
Can we tell whether it's come from Krakatoa? And that's more difficult. We can see it in Antarctica and we can see it in Greenland, so that tells us it was probably somewhere mid-latitude, so somewhere round about the equator maybe. So it's a possibility, but we cannot really pin it down at the moment.
Despite this uncertainty, there is no doubt of Krakatoa's capacity for destruction. The steep cliffs at Krakatoa show that Krakatoa collapsed to form an enormous caldera, triggering a deadly tsunami. And yet ice cores from Antarctica suggest that Krakatoa may have exploded before, with even more force than 1883. To discover what originally created not only 1883 Krakatoa, but also the current Anak Krakatau, scientists will have to travel even further back in time. Some 2 million years. The source of Krakatoa's awesome power remained a mystery to scientists for centuries. One clue is its location. Indonesia contains more volcanoes than anywhere else on Earth.
Indonesia is a jackpot for volcanologists, simply because the evidence of volcanic centers that may have lasted several million years are available and ready for observation and study.
Incredibly, there are 21 of these fire mountains on the island of Java alone, an area the same size as New York State. The National Park of Tengah in East Java is one of Indonesia's most active volcanic zones.
To view a landscape like this is actually humbling, because it tells us that there are forces at work that far exceed anything that mankind can construct.
But why there should be so many volcanoes in such a small area, no one could explain. A key discovery was that Indonesia lies adjacent to the notorious Ring of Fire, a chain of volcanoes stretching around the entire Pacific Ocean. In the 1950s, American geologist Harry Hess began research into the groundbreaking hypothesis known as seafloor spreading. This laid the foundation for plate tectonics. Plate tectonics is based on the idea that our planet is not a perfect and unbroken sphere. It's composed of 8 major tectonic plates that jostle and jar against one another. These plates are driven by heat from the planet's core. Here in Indonesia, the plates collide faster than almost anywhere else on Earth. The volcanoes here are created when the heavier oceanic plate is pushed under the lighter continental rock. This is subduction. When the rock is pushed deeper, it melts to produce magma. Over thousands of years, it builds up into a vast magma chamber many miles beneath the surface of the Earth. Eventually, the pressure of the extra magma becomes too great for the Earth's crust. The magma forces its way up to the surface in a storm of hot ash and boiling lava. A volcano is born. In the case of Indonesia, this is a nation constructed almost entirely from volcanoes.
Most of Indonesia is in fact composed of volcanoes that initiated from somewhere down below sea level, rose up to sea level, and then grew as islands and amalgamated to form bigger land masses that now comprise the Indonesian nation.
Using the theory of plate tectonics, scientists can rewind the clock. 45 million years ago, the Australian plate started to move north rapidly. The island chain of Indonesia began to emerge from the ocean at the point where the two plates collided. Vast numbers of volcanoes exploded as the Australian plate was pushed deep into the bowels of the Earth. Krakatoa was a product of these same forces. And it was 2 million years ago, as our early human ancestors were taking their first tentative steps, that the volcano was created.
So the fact that under the Sunda Straits of Indonesia you have all these processes taking place 70 and 80 miles down below the surface made it inevitable that a volcano like Krakatoa came into existence, but also had a catastrophic eruption.
What made Krakatoa so much more dangerous than hundreds of other volcanoes in Indonesia only became clear in 1988. Scientists discovered that large clusters of earthquakes were taking place beneath the Sunda Straits. Earthquakes are common along plate boundaries, but this amount was off the charts. This major clue would enable scientists to finally identify the killer factor in Krakatoa. Beneath Krakatoa, in the middle of the Sunda Straits, the subduction zone contains a kink. This twists and rips the Earth's crust and provides even more material to fuel Krakatoa's hungry magma chamber.
Where you have those kinks, two things can happen. Firstly, there might be a greater chance of earthquakes because the kink itself actually starts to tear or rip. And secondly, where the kink is might generate more melting. And it's the melting that takes place in the mantle that ultimately leads to the lavas that erupted from the volcanoes at the surface.
Finally, the origins of Krakatoa had been revealed. Hundreds of volcanoes in Indonesia show that the country lies on a volatile plate boundary. Unusually high numbers of quakes show that Krakatoa lies on a deadly kink within this zone. But can scientists now use this knowledge to predict Krakatoa's future? A prediction that is today more important than ever, because the volcano is back, and it's getting bigger every day. Today, these shattered islands are all that remain of the cataclysmic 1883 Krakatoa eruption. But a deeper understanding of this event is now more important than ever, because out in the Straits, a new threat is growing. Krakatoa is back, in the form of Anak Krakatau, Indonesian for Child of Krakatoa. And that child is now an angry teenager. Like a phoenix from the ashes, Anak Krakatau is growing directly over the site of the original Krakatoa volcano, leading scientists to conclude it's being fed by the same magma chamber deep beneath the Sunda Straits. This deadly heritage means that Anak could potentially be one of the most dangerous volcanoes on Earth. But just how immediate is this threat? Since its explosive beginnings in 1927, Anak has erupted frequently and violently. As one of the fastest growing volcanoes on the planet, this 1,033-foot-high mountain bears watching. Predicting exactly when another major eruption will happen is difficult, but there are clues. Underground tremors are a sure sign that the magma deep within the volcano is starting to move.
We have seismometers stationed on the volcano that tell us when rocks are breaking not just at the vent, but in the subsurface, heralding the arrival of new fresh magma into the edifice, into the cone.
These details are transmitted via radio signals to the monitoring station on the mainland, which is operated 24 hours a day. They have a simple scale to measure the threat, running from 1 to 5. Anything above a 3, and they go on red alert. At the moment, it's hovering around the danger zone, a level 3. The type of magma within the volcano is another way geologists can judge the potential of a major eruption. But the magma itself is impossible to test, as it lies several miles deep within the Earth. The next best clue is to look at what has been literally thrown out of the volcano. Lava bombs.
I've got my hand on a basaltic andesite scoria bomb that was probably blown out of a vent about 3/4 of a mile from here, and you can imagine to be hit by one of these would not be a good situation. These can actually range up to things that are the size of refrigerators and television sets, and they're thereby making them even more lethal, particularly when they're traveling at 120 miles an hour.
Mandeville analyzes these rocks made up of basaltic andesite, which will give him a clue to the makeup of the magma deep underground.
Part of what this composition tells me is the composition of magmas being erupted at Anak are unlike what was typically erupted at the 1883 eruption of Krakatoa, which was much more silica-rich and much lighter in color, typically light beige to almost white.
The more silica in the magma, the more viscous or sticky it is. And that's what contributed to Krakatoa's explosive eruption in 1883. The explosive gases were trapped in the magma, and pressure had been building up over time. Fortunately, the dark color of the lava bombs from Anak Krakatau are evidence that the magma is low in silica. And the explosive gases have yet to reach critical 1883 levels. But this is not a permanent state.
Over the years, a magma like this can, in fact, evolve into something that was that explosive.
As Anak Krakatau grows, the magma will certainly become thicker and stickier. As in its parent, once the magma gets too sticky, the vent could become blocked. The silence could signal disaster. It means that pressure could be building up inside. Too much pressure, and Indonesia could suffer another cataclysmic explosion. More than 100 years of investigation into Krakatoa has helped unlock the secrets of its past and provided scientists with strong evidence that Anak Krakatau is following in its footsteps. The pumice from 1883 suggests that Krakatoa was a deadly stratovolcano. The stripes in the pumice show that the massive 1883 eruption was triggered by an injection of superhot magma. It was this that blew the volcano to pieces. The remains of vast pyroclastic flows that were over twice the height of the Empire State Building, plus the immense caldera, show the massive scale of Krakatoa's 1883 eruption. But most ominously of all, the position of Anak Krakatau near the deadly ring of fire directly above a kink in the subduction zone means that a future massive eruption is inevitable.
A lot of the Anak Krakatau activity that we now witness today is actually almost a continuation of the volcanic activity that took place back in 1883. We could have another eruption here on the scale of the 1883 eruption of Krakatoa.
The 1883 eruption of Krakatoa may be the most famous, but it is a geological certainty that it won't be the last. Krakatoa is on the rise again. Dynamic proof that the Earth is never at rest.